Dear friends, welcome to a lecture on complex analysis. In this lecture, we shall study the second theorem on limits. In our earlier lecture, we have studied first theorem on limits of functions. There we have considered the function as f of z, say function having u plus iv. Then if its limit is say w naught, limit as z tends to z naught of u plus iv, this function is equal to u naught plus iv naught, w naught. And then what this implies is limit of u. So, limit of real part is equal to the real part of the limit, and that is limit of u as z tends to z naught is equal to u naught, and limit of v as z tends to z naught is equal to v naught. So, this we have proved in our earlier lecture, that is theorem 1, lecture previous to this. Please watch that lecture, and using that lecture we will prove this theorem, second theorem. What the second theorem states, that if there are two functions, small f of z and capital F of z, the limit of small f of z at z tends to z naught is w naught, and the point is the same, limit of capital F of z at z tends to z naught is capital W naught. Then the algebra of these functions, limit of algebra of these functions is expressed here, that is limit the sum of the two functions f of z plus capital F of z is equal to W naught, small w naught plus capital W naught, means actually the limit of first function plus limit of second function. That is, limit of sum of two functions is equal to limit of first function plus limit of second function. And similarly, the product of two functions, limit z tends to z naught f z into capital F of z. The same theorems we have studied in real analysis also, or in calculus, and what this states, this is equal to limit of first function small f, that is w naught, into limit of second function, that is capital W naught. And for the quotient, the condition is w naught not equal to 0, because it is the denominator. So, if this w naught is not 0, then limit of the quotient of small f and capital F is equal to the quotient of w naught divided by capital W naught, that is the limit of f of z divided by limit of capital F of z. So, these are the theorems, and here the same theorem holds for subtraction also. In place of addition, if you write minus, then here will be the subtraction sign. And now we will prove this. So, the first theorem I will leave for you to prove, we will prove the second and third. The proof for second we shall have. See, we have this z as x plus iy. So, we will consider this z is equal to x plus I into I, or let z naught is equal to x naught plus I y naught, and you see w naught, and w naught we have to consider as w naught is equal to u naught plus I v naught. Capital W naught we will consider as, see, capital, or before that we will consider f of z. F of z is equal to u plus iv, and capital F of z we shall consider as capital U plus I into capital V, expressed in real part and imaginary part. Further, we will express w naught in the form of let w naught is equal to u naught plus I v naught, and capital W naught is equal to capital U naught plus I capital V naught, that is. And what is given here is limit f of z is w naught, given limit f of z tends to z naught is equal to w naught, and limit z tends to z naught of capital F of z is equal to capital W naught. So, this by theorem 1 we have as z approaches z naught, this limit of f of z is w naught. What is f of z? U plus iv. And what is w naught? U naught plus iv naught. So therefore here real part u approaches u naught, or that is the limit. See, u approaches u naught, or actually limit of u is equal to u naught, that is written in this form. And v approaches v naught means limit of v is v naught, limit of capital U is u naught, and limit of capital V is v naught. So this is by theorem 1. In place of limit I have written here this symbol. Here actually limit u is u naught as z tends to z naught. See, as z tends to z naught, we have u approaches u naught, etc. Actually these are the limits. Now we are proving the second part of this second part of the theorem, and for that purpose, what is second part? The product of small f and capital F. So small f of z into capital F of z is, small f of z is u plus I into v, and capital F of z is capital U plus I into capital V. And this product of two complex expressions, we know it is u into capital U minus product of this imaginary part iv into I into capital V, that is v into capital V, that is real part, plus I into imaginary part is, this is v into capital U and plus u into capital V. This is f z into capital F z, and now we want to take limit of this. So limit of this function is to be considered by theorem 1. Limit of this expression is equal to limit of real part plus I into limit of imaginary part. Now what is the real part is u v minus v into v. We will write the limit of this. So limit of real part, limit of real part, this is limit as z tends to z naught of u into capital U minus v into capital V, and this is equal to, as we have written, u approaches u naught as z tends to z naught. This is theorem 1. V approaches v naught, etc. So therefore u into v, capital U will approach u naught, u naught. So u into u will approach to this point, minus this will approach v into capital V will approach to this point, and limit of imaginary part will be now similarly. So I shall write here limit of imaginary part. And what is what will the limit of imaginary part is? Limit z tends to z naught of, what is the imaginary part? V into capital U minus u into capital V, and this will be v naught u capital U naught minus u naught capital V naught. So this is the limit of imaginary part. Now we use this in this expression. So therefore limit of f z into capital F of z is, therefore limit z tends to z naught of small f of z into capital F of z will be equal to limit of this expression, that we will have limit z tends to z naught of u into capital U minus v into capital V plus I into, see this is v capital U plus u capital V you should differentiate between small and capital letters, and this is equal to, now we have written here what is limit of this part, real part, that is u naught etc., this one. So this is u naught capital U naught minus v naught capital V naught, and this one is I, is a constant, v naught capital U naught plus u naught capital V naught, and this we can write as, this can be written in the product form as u naught plus I v naught into capital U naught plus I into capital V naught. You may verify this, u naught minus v naught capital etc., this, and what is this? This is limit of f of z, small f of z, and what is the second is limit of capital F of z. Actually this is w naught, this is w naught we have written earlier here, this is equal to limit of small f z, and this is limit of capital F z, which is w naught into capital W naught, and this proves the second result, hence result second. Now what about the third one? To prove the third one, this we shall prove. For this first we shall suppose w naught is not equal to 0. That is necessary because w naught is at the denominator. Third, let w naught not equal to 0, and to prove this result we will make use of the second result, product. So this quotient can be expressed in the form of product, that is f of z into 1 over f of z, and thus to express we will express in this form, and to get this result using the second result, so we need to find the limit of this. So this will be in the form of product, limit of first into limit of second, and this second limit we shall first obtain, 1 over f of z, and we shall find, we shall obtain limit z tends to z naught of 1 upon f of z. Now for that purpose we shall first express 1 upon capital F of z. 1 upon capital F of z is equal to 1 upon, what is capital F of z we have written earlier, that is u plus I into v, and we shall rationalize this, and to rationalize this we know we have to multiply the denominator by its conjugate, this conjugate of this, that is u minus I into v, and the numerator also to be multiplied, and this is now, so this expression will be this, that is 1 upon f of z is equal to, now see the denominator is in the form of a plus b, a minus b, that is a square minus b square, and this will be u square minus I square v square, and that will be u square plus v square, because I square is minus 1 and the numerator is u minus I into v, and this we can write in the form of real part and imaginary part separate, that is u divided by u square plus v square and plus I into minus v divided by u square plus v square. This is 1 upon f of z, and now we shall find out its limit. So therefore limit z tends to z naught of 1 over f of z is equal to limit of this, limit z tends to z naught of this u divided by u square plus v square, capital letters, and this is plus I minus v divided by u square plus v square, and by theorem 1 this is, see, limit of real part plus limit of imaginary part, and we know the limit of this expression is u naught divided by u naught square plus v naught square, because u tends to u naught or limit of u is u naught etc. we have written limit of capital V is capital V naught, and plus I minus v naught divided by u naught square plus v naught square, and this is same in this part. See, instead of u v here we have u naught v naught etc., and this expression is same as this one, and this is same as this expression, and here this will be 1 over u plus I v naught, and therefore this is exactly 1 upon u naught plus I v naught. You see, it is the similar expressions here, and but what is this? This is w naught. So, 1 upon w naught, and thus what we have proved is limit z tends to z naught of 1 upon capital F of z is equal to 1 upon w naught when w naught is not equal to 0. And now we will use this result to obtain the limit of quotient. Now, see, limit z tends to z naught of small f of z divided by capital F of z. We shall express this in the form of product. This is f of z into 1 upon capital F of z. Quotient is expressed in the form of, and now this for this we shall use the second result. So, what about this? Limit of f of z into capital F z is limit of f of z into limit of capital F of z, and therefore this will be, this is equal to limit z tends to z naught of small f of z into limit z tends to z naught of 1 upon capital F of z, and what is this is small w naught, as here it is given, and what about this limit is we have obtained here. This is or we may suppose this as statement 1, if not written earlier, then this is 1 upon w naught, or this is w naught divided by capital W naught. W naught, capital W naught is not 0, and thus we have proved this result. This result we have proved, and in this way we can prove the results of regarding addition of two functions, multiplication and quotient. So, for this addition you may try in the similar way, and similarly the result holds for subtraction also. This is minus, then it will be negative. So, please try for these two results yourself. Thank you for watching the lecture.